All right, this is Algebra 2, Lesson 29 on page 131. Uniform motion problems. That is distance equals rate times time. That's the uniform motion problems. Uniform means the rate doesn't change. Like I don't go 50 miles per hour like people on the interstate, right? They go 70, then they go 60, then they go 75, then they go 50. Like just set your cruise. That's uniform motion problems. People setting their cruise control and going. Same rate. That's why it's called uniform. All right. Before now, we have had where the distances were equal. The distance of one person equaled the distance of the other person. Now, we're going to say we're going to add their distances. So it's sort of like, okay, Miss Haley and Mr. Brewer. We start here. Okay? Mr. Brewer goes home in this direction. All right? So this is Brewer. All right? Miss Haley goes home in this direction. So that's Haley. And at some point, we are 50 miles apart. Such that the distance of Mr. Brewer plus the distance of Miss Haley is 50 miles. Got it? So we're going to be adding distances to equal a given distance. So this would be rate Brewer time Brewer plus rate Haley time Haley equals 50. Make sense? But they're going to be in word problems. All right, so look at the first example on the top of page 132. Napoleon walked part of the 60 miles. So he must have walked some, and I don't know what he did, but it's part of the 60 miles he walked to the battle site. Oh, and then he rode the rest. So the distance rode. So the distance walked plus the distance that he rode is a total of 60 miles. Well, this is rate walked time walked plus rate rode time rode is 60 miles. Now it's going to give us some more information. He walked at 3 miles per hour. What is that?
That's a rate.
That's the rate walked, right? Equals 3. And he rode at 9 miles per hour. What's that?
That's the rate of the ride, which is...
Yes. If the total time of the trip was 8 hours, what's that?
T. That's TW plus TR equals 9.
All right, so we've already had problems where all the information is given. You are always substituting in the last 3 into the first one. But because I have 2 variables in this equation for time, I want to solve for one of them and use substitution. So do we want to solve for time walked or time rode? Almost said ran.
We want to solve for time walked.
Okay,
so we're going to subtract time ran on both sides.
There we go. So this is what we're going to put in for TW. All right? All right, so the rate walked is 3. For TW, we're going to put in 9 minus TR. The rate walked is 6. We're going to leave TR as TR because at this point you only want one variable. And it equals 60. So distribute the 3.
27.
So we end up with 27 minus 3TR plus 6TR equals 60. I'll subtract the 27 from both sides and combine my like terms which makes it 3 TR equals, what is that, 33? Is that 33? So dividing by 3 on both sides, the time that he rode was 11 hours. If he rode, that's not possible. That's crazy.
I walked for negative.
No, we didn't walk. What did we do wrong?
The rate of R is supposed to be 9, I think.
The rate of R is 9 instead of 6. I wrote it wrong. It is 9. Okay, so let's go change this to 9. But that was good because this didn't make sense. It was not logical. Why is this not logical?
Because he only walked.
Because then he walked negative hours. Time can't be negative. Okay, so we have to go back and change this to 9. Change the rate of R to 9. The rate of R to 9.
Miss Haley,
Yes.
see, W plus CR is 8.
This I totally wrote this wrong. Did I pull it from somewhere else? I have no clue. 8. This is 8 hours. This is 8. I totally did this wrong. So this is 8. Let's go back here. This is 8. Thank you. Did y'all know this all along while I was... Okay. Just making sure, because y'all know y'all need to call. Just call my attention to this. Okay. 3 times 8 is 24. That's minus 3 TR plus 9
It should be 8
TR.
TR.
What?
Oh wait, never mind.
8.
Never mind.
Got it? Is that right? Equals 60. So we'll subtract our 24 and combine our like terms. That's 6 TR equals, what is that, 36? Well, we still got 36.
No, that means that dividing both sides by 6, the time written is 6 hours.
That makes sense.
And so now.
All right, so we're going to put these back in. Rate, that's 3 times, what's the time of W?
2.
2. So putting it back in, we always go back and put it in. 3 times 2, he walked 6 miles. And the distance he rode was 9 times 6, which is what? 54? 54 is 9 times 6. So that equals 60 miles. So always go back and put it in. So you're going to struggle with these just like I did. But number 1, I just wrote down the wrong numbers, all right? But if something is illogical at the end when you substitute them back in, you should be able to catch whether or not you worked it correctly. All right, let's go on to number 2, example 2. I will pay closer attention. Y'all might pay closer attention too, huh? Okay. Edward Longshanks and Queen Eleanor were 54 miles apart. Okay, so Edward is here. The Queen is here. They are 54 miles apart. They're going to start traveling towards each other. So the total distance that they're going to travel is 54 miles. So the distance of Edward plus the distance of the Queen is going to be 54 miles. Now, if I'm the Queen, I'm taking my time and making Edward go further. So let's see what happens. Edward began the journey to the meeting place at 8 a.m. So Edward begins at 8 a.m. at 3 miles per hour. So the rate of Edward is 3. 2 hours later, so the time of the Queen is 2 hours later. Or I could write the time of the Queen is what?
Time of Edward Edwards plus 2. No,
Well, does she travel 2 more hours or 2
No.
fewer hours?
2 fewer hours, so minus.
2 fewer hours. Okay, so I'm just thinking ahead. Is Edward's time minus 2 because he's been traveling 2 hours longer. All right, just thinking ahead. Don't know which one I'm going to have to use. 2 hours later, the queen set out to meet him. It doesn't tell me the rate of the queen, does it? They meet at 4 p.m. Okay, so now I already know the times. If he starts at 8 a.m. and they meet at 4 p.m., what's the time of Edward?
8 hours.
He's been going 8 hours, so the time of Edwards is 8, and the time of the queen is 6 hours. All right, this one's easy. I just have one variable. So distance equals rate times time. I just don't know the rate of the queen. Of course, she's probably being carried, right? She's probably not walking. All right, so the rate of Edwards is 3. The time of Edwards is 8. We don't know the rate of the queen, but she's been traveling for 6 hours to get to 54 miles. Okay, so this is 24. 3 times 8 is 24. I'm going to subtract 24. Well, the queen, he makes that queen go further than him. So 6 times the rate of the queen is 30. What's the rate of the queen? 5 miles per hour. Of course. She's faster than him. Okay. That makes sense, right? Because that's 24, that's 30, that's 54 miles. See how I just make sure I've not just neglected to think through things. Make sure it makes sense. Last example, you ready? Okay. At noon, Rocket Man. Okay, time of Rocket Man. So he's at noon. I'm just going to write 12. Whizzed off toward Rocket Land. 1 hour later, Moonfa. So this is the time of Moonfa. What a name. Don't ever name your kid that. So 1 hour later, so he's at 1 o'clock. He whizzes off in the opposite direction. So they're together and they go in opposite directions. Oh wait, look at Moonfa's speed. What does it say about Moonfa's speed? Read it. What does it say? Whizzed off in the opposite direction at a speed of 200 kilometers per hour, less than that of Rocket Man. So what do I write?
You write
His rate is
equals
200
Rocket Man's rate minus
less than the rate of Rocket Man. If at 5 p.m., so now we're at 5, they are how far apart? 11,800. So the distance that Rocket Man has traveled plus the distance Moonfa has traveled is 11,800 kilometers. How fast did each one of them travel? Do I know their times? Yes, I have a start and a stop. So what's the time of Rocket Man? How long did he travel?
5 hours.
5 hours, from noon to 5. And how long did Moonfa travel?
4 hours.
4 hours. And then I'm going to use this to substitute in so that I only have one variable. Because distance equals rate times time. And I'm going to leave the rate of R in as rate of R. The time of R is 5. But for rate of Moonfa, this is what I'm going to substitute in. It's going to be the rate of Rocket Man minus 200. And his time is 4. That's going to equal 11,800. So this becomes 5 rate of Rocket Man plus, I'm going to distribute the 4. 4 rate of Rocket Man minus 800 equals 11,800. I'm going to add 800 to both sides. Combine my like terms on the left hand side. So then I have 9 rate of Rocket Man equals 12,600. And divide that by 9. Somebody tell me what the rate of Rocket Man. What's 12,600 divided by 9? Say that again. 1,400 kilometers per hour. If that's the rate of Rocket Man, what's the rate of Moonfa? That minus 200, which is 1,200 kilometers per hour. And I'm always going to check myself. Does the rate times the time equal that distance? Okay, so does 1,400 times 5 plus 1,200 times 4
Yes, ma'am.
equal 11,800? It does. I'm always going to check my answer.